on how it's made. Thinning shears. Wagon wheels. Toaster pastries. And violin bows. Thinning shears are scissors with at least one comb-like blade. When the blades come together, some hair falls between the teeth of the comb and that hair is cut, while other strands are left intact. A few quick snips, and this handy tool can do a lot for your style. It's often necessary to go to many lengths to achieve the right look. Stylists use thinning shears to layer a cut from the inside. This removes bulk to give hair height. When it comes to improving your hairdo, thinning shears definitely have the teeth for the job. They start with stainless steel rods. The rods ride a magnetized conveyor up to an induction heater. It heats each rod from the ends until it becomes white hot and soft. The rod is now ready for forging. A worker moves the hot rod back and forth over a die as a hammer slams it into it. This flattens and forms it into the shape of two scissor blades. The forging leaves a lot of excess steel around the blades. They cut away that excess. Reheated now, a worker plunges the blades into a lead bath. Then he dips them in oil, standing back as they flame up. The lead bath and the quick cool down harden the steel. Another worker then clamps a blade into position. A cutting wheel rolls into action and carves a comb profile into the blade. A constant flow of water-based coolant keeps the temperature of the cutting wheel and the scissor part down. Otherwise, the cutting process could cause them both to overheat and compromise their strength and integrity. This is the thinning scissor blade before cutting, and this is the blade with its new teeth. At the next workstation, a robot transfers a blade to an automated grinding machine. The machine grinds both the front and sides of the teeth to smooth the rough edges. This robotic system processes up to 150 scissor blades an hour. Next, it's into a tumbler filled with synthetic pebbles. As the thinning blades bounce around, friction happens. This smooths more rough edges, especially the handles and finger rings that didn't undergo grinding at the robot station. After about 4 hours, a magnetic conveyor retrieves them. Then the midsection, where the two blades are to be joined, receives hands-on attention as a worker smooths it using a fine abrasive sanding belt. They move on to the straight scissor blade. An employee hones it against a horizontal grinding wheel. This aligns the cutting edge. He inserts threaded screws in holes in a straight-edged blade and in the corresponding comb-like blade. He brings the two together and then tightens the screws to a specific torque. Too tight or too loose, and these thinning shears won't operate smoothly. With an emery board, he gently files the shears to get rid of lingering dust from the extensive grinding. He now tests their function. It isn't entirely smooth, so he hammers a section of the comb blade to level it. It now moves more freely against the straight blade. And now, the ultimate test. He tries them out on a lock of artificial hair and confirms that these thinning shears are as sharp as they look. Next, the blade comes up against a spinning leather belt. This takes it from merely sharp to razor sharp. It also polishes the blade to a mirror finish. A computerized laser burns the brand name and model information into the shears. They screw a brass nub to the finger ring to give the pinky finger something to rest against. These thinning shears are now ready for shipment. Soon, they'll be in the thick of things at the beauty salon. Wooden wagon wheels rolled through the tumbleweeds of another time. Fixed to covered wagons, they transported settlers to the American West in the 18th and 19th centuries. There are now cities and freeways where wagon wheels once blazed trails, but making them is not a lost art. A thriving nostalgia industry keeps these big wooden wheels turning. Wagon wheels are in demand for historical reenactment events, museums, and the movies. The wheelwright carves the hub from a chunk of strong, rot-resistant oak. As it spins on a lathe, he cuts it to length. He stops the lathe and marks measurements for the wagon wheel's profile, sizing it for reinforcing metal hoops. He resumes carving, using the penciled lines as a guide. He transforms the oak blank into a barrel-shaped design, which is traditional for wagon wheel hubs of the 1870s. With the hub now clamped in another machine, he uses a mechanized chisel to punch out rectangular spoke holes known as mortises. He angles the edges of each hole to receive the tenon end of the spoke. He slides steel hoops onto the hub at the ends and in the center. It's a snug fit, but it's not quite tight enough. A hydraulic press squeezes the hoops around the hub to provide just the right tension. The hoops will act as a constricting force to keep the wood from splitting. From a chunk of wood into a substantial wagon wheel hub. Now, using tools called spoke shaves, the wheelwright shapes the hickory wood spokes. He narrows the throat of the spoke to add flexibility where it's to be inserted into the hub. He coats the mortises of the hub with glue. He inserts the spokes into the glued holes. He drives them into place with a sledgehammer. There are 12 spokes in total for this front wagon wheel. The wheelwright then spins the wheel and eyeballs it to confirm that the spokes rotate on an even plane. Then, like sharpening a pencil, he brings the ends to a point. This prepares them for the tenon cutter, which now carves them into peg shapes for insertion into the wheel rim. He installs the steam-bent wooden rim in 2 sections. It's drilled to match up with the spokes. At first, it's easy, but as the tension builds, it becomes tougher to insert the remaining spokes. So he stretches the rim wider with a clamp. This gives him more room to maneuver as he fits the others into the rim half. In the process, he creates a slight bow in the plane of the wheel. It's a truss-like state that adds strength to the wagon wheel. Now, using an electric roller machine, he bends a strip of steel into a round wagon wheel tire. It takes just one pass through the rollers to achieve the desired bend. The length will need to be precisely measured. He measures the inner circumference with an old wheelwright tool called a traveler to determine just how much tweaking it needs. Then, using a torch, he cuts the tire to the exact length required. He makes the tire slightly smaller than the wheel itself because it must serve as a heavy-duty elastic band to hold the assembled wagon wheel together. He welds it where the ends meet, and this completes the wagon wheel tire. He now bakes the tire briefly in an open fire. The metal expands, and at a strategic moment, they pull it out of the flames. The tire has stretched to the point where it can be installed on the wheel, but it's not quite hot enough to cause the wooden wheel to catch fire. They pour water onto the tire to bring it back to a cooler temperature. As it cools, it shrinks to the wagon wheel, creating that elastic band effect. Next, they prime and paint a matching set of wheels in the color of the client's choice. And with those finishing touches, these wagon wheels are en route to the past. For fans of American history, it's sure to be a sentimental journey. For people who need to grab a quick bite for breakfast, the invention of the toaster pastry in the 1960s was the greatest thing since sliced bread. Finally, the toaster could be used for more than toasting bread, and the toaster pastry was definitely a sweet alternative. The toaster pastry retains its sweetness during toasting. The syrupy filling and frosting don't melt out and into the toaster. It's all because of the ingredients and how they come together. At this factory, they start by making an organic pastry. The blender operator loads dry ingredients like rice bran into the blender, followed by a sugar syrup and molasses. It's the molasses that gives the pastry a brownish color. He adds organic palm shortening and organic granulated sugar. The flour and water are piped into the blender barrel. Spiraling mixers blend and knead the dough to the desired consistency. Next, it's into a hopper that feeds the dough between 2 rollers. They squeeze and flatten the dough into a sheet that's about 2 centimeters thick. A conveyor moves the toaster pastry dough forward to sets of larger rollers. They apply serious pressure to roll the dough much thinner. Wheels at the sides fold back the dough as the width expands. A dusting of flour to the rollers keeps things from getting too sticky. Coming off the final rollers, the thickness of the dough has been reduced to 1/6 of a centimeter. At another station, they've whipped up a batch of cherry pomegranate jam. The jam is hearty and thick, so it won't run, as nozzles pump the jam onto the rolled pastry sheet. Each toaster pastry receives 3 strings of jam. This depositor system fills 10 tarts at a time. It works out to 390 tarts a minute. A second sheet of dough heads towards the jam-filled one. En route, a spiked roller punches holes for venting steam during baking. Without these holes, the pressure would build and the toaster pastries would explode. The top sheet of pastry now merges with the bottom one. The conveyor belts move at exactly the same speed, so the top pastry lands in perfect alignment on the jam-filled one. A cylinder with a brass grid pattern bears down on the pastry to compress it between the jam fillings. This forms pockets of jam. A cylindrical blade slices the pastry into individual tarts. A device pulls off the side trimmings. The toaster pastries travel through a 46-meter-long convection oven heated to 150 degrees Celsius. The operator keeps a close watch for leaking jam that would be a sign of bad seals in the pastry pockets. He rejects any with leaks. He also keeps an eye on the color as the pastries brown. They shouldn't be too dark or too light. Fresh out of the mixer, the pink frosting now flows onto a revolving belt that spreads it on the toaster pastries at just the right thickness. They've added a bit of starch to the icing. And it's this starch that allows the icing to harden and set so it won't melt and drip into the toaster during toasting. They sprinkle granulated colored sugar onto the toaster pastries. They call this topping the crunchlets. The crunchlets add both flavor and texture to the pastry. Once cooled, the toaster pastries transfer from one conveyor to another. A breaker roller snaps them at the crimp line to separate them into groups of 2. The completed tarts head towards the packaging line. An operator does a visual inspection as they pass by. Mechanical arms push the tarts into aluminum wrapping. Hot rollers seal and cut the wrap at the ends. This wrapping preserves the tarts for 8 months. No preservatives needed. Suctioning arms grab and open cartons to accept the foil-wrapped toaster pastries. It takes about an hour to manufacture a box of toaster pastries. And now, it's time for a toast. The type of bow used today for instruments in the violin family originated in France in the 1800s. The master bow makers of the day used Pernambuco, a wood being imported from Brazil to make textile dye. They considered this wood ideal due to its strength, durability, and beauty. Today, just like hundreds of years ago, quality bows are made of Pernambuco wood from Brazil and horsehair. To make the wooden part, called the stick, the bowmaker lays a template onto an 11 to 13 millimeter thick block of Pernambuco and marks where he'll make his cuts. He follows his markings with a bandsaw, cutting out the stick's basic shape. Then he planes the stick, thinning it out, tapering it to narrow toward the front, and angling the corners to make the square contour octagonal. Next, he repeatedly heats the stick with a gas flame to soften it, and gently bends it against his knee, then afterward against a wooden form, to give the stick a very precise curve. This is referred to as the camber of the bow. Using a handsaw and template, he cuts out a piece of Pernambuco for the bow's front tip, called the head. He refines the shape, first with a rasp, then with a file, then with sandpaper. Then he glues on a bone plate to protect the head from damage. He wraps string tightly around it to apply continual pressure while the glue sets overnight. The next day, he files down the sides to make the plate flush with the wood. Using a traditional drill, he bores a hole about 10 millimeters deep into the head. and chisels the hole into a trapezoid shape. This forms the hair block into which he'll later insert the hair. Next, he measures and marks a block of ebony wood to begin making the bow's frog, the piece at the bottom by which the musician holds the bow and adjusts the tension of the hair. He shapes the block using first a saw, then a chisel, and rasps, files, and sands all the surfaces smooth. The frog has a space on top called the mortise, into which he'll later insert the hair. The bowmaker glues a decorative mother-of-pearl accent onto the side, then cuts 2 small plugs out of maple wood. These will anchor the hair at each end of the bow. He inserts one into the frog's mortise and the other into the hair block in the head. A bow this size requires 5 grams of hair. That's approximately 180 horsehairs. The bowmaker bonds them at one end with some melted rosin, a sticky plant resin. Then inserts this end into the frog and anchors it with the plug. Then he bends the hairs and slides on a nickel-silver ring called a ferrule to hold them together. More expensive bows often have a gold ferrule. To mount the frog, he inserts a long metal screw with an adjuster head into a hole drilled into the back of the bow. The screw operates an eyelet connected to the frog. Now he combs the hair straight. The individual hairs must be parallel to each other for the bow to perform properly. He ties the loose ends together with thread and bonds them with rosin. Then he inserts the sealed end into the tip and anchors it with that second plug. Back to the frog now. He moves the ferrule out of position, seals the mortise with a mother-of-pearl slide, then puts the ferrule back. He wraps the parts of the stick the musician holds in silver or gold wire and leather to protect the wood from wear, and brands the maker's name on the bow. Turning the adjuster at the back moves the frog forward and backward to alter the tension of the hair. The violinist tightens the hair before playing and loosens it when putting the instrument away.